There's this thing called remote sensing. You might have heard of it before, but do you really know how it works? In this video, we explain everything you need to know about remote sensing in 100 seconds so that you can sound smart when people bring it up. No joke, let's do it. 1 minute, 1 Okay, let's go. Remote sensing is like taking a picture of the Earth from space. Satellites equipped with special cameras capture images of the Earth's surface without any human intervention. These satellites orbit the Earth and act like our eyes in the sky, constantly capturing images and sending them back to us. How does remote sensing work? Well, the sensors on these satellites capture images using electromagnetic radiation. They can see things beyond the visible spectrum, like infrared and microwave radiation. Different materials on Earth reflect and absorb different types of radiation. So by analyzing the data, we can identify things like vegetation, water bodies, and even changes in land use over time. There are three main types of remote sensing technologies. First, optical remote sensing, which is like what your eyes would see, used by satellites like Landsat and Sentinel to capture Earth's images. Then radar remote sensing, which uses radio waves to create images. This can see through clouds and darkness, perfect for night or bad weather shots. And finally, thermal remote sensing, which detects heat signatures on Earth, useful for tracking wildfires, cities, and even oceans. Major remote sensing satellites include NASA's Landsat program, which has been capturing images of the Earth since the 1970s and is considered the longest-running and most comprehensive Earth observation program ever. The European Space Agency's Sentinel satellites, which provide high-resolution images for environmental monitoring. And more recently, private satellite companies like PlanetScope and Maxar, which offer commercial remote sensing services. Okay, so you might be wondering why we do this. Like, what can we actually do with all this satellite data? Well, remote sensing has tons of applications. It helps us monitor the environment, track deforestation, rising sea levels, and other effects of climate change. It helps farmers with precision farming by providing data on crop health and soil conditions. It even helps emergency services track hurricanes, floods, and wildfires in near real time. City planners use it for urban development, infrastructure monitoring, and smart city initiatives, and that's just the tip of the iceberg. At its core, remote sensing is all about collecting data, and that data can be used in Geographic Information Systems, or GIS, to create maps and analyze land use, population density, vegetation, and more. In fact, many of the maps you see on our channel are created using satellite imagery and other remote sensing data. The future of remote sensing is really exciting. Advances in artificial intelligence and machine learning are making it easier to analyze vast amounts of data and extract valuable insights. Small satellites, or CubeSats, are also changing the game by providing more frequent and detailed imagery. And hyperspectral imaging is becoming more common, allowing us to see even more details on Earth's surface. Of course, there are some challenges. Cloud cover can obscure our view of Earth. Data resolution isn't always high enough and costs can be prohibitive. But as technology continues to improve, remote sensing will continue to provide us with valuable insights about our planet. So the next time someone brings up remote sensing, you'll know just what to say. Thanks for watching.